Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a continuation of half-angle identities in trigonometry. It is assumed that you've watched all the videos or have knowledge of the trigonometric identities for the sum and difference of angles, the double angle formulas or identities, and then the half-angle identities prior to watching this video. In this video, we're just going to use these half-angle identities in more abstract settings. So here's this first example. We have the cosine. Somebody handed us the cosine of an angle A equaling 1/2 with A in quadrant 4. Now, to be honest with you, we could find that angle A. So this is somewhat of a trivial example, but let's actually change it up. Let's suppose that instead of 1/2, because I dislike that, let's call this angle, or this ratio 1/5. Because if it's 1/2, you could tell me very quickly what the cosine of what angle that is. But if it's 1/5, you can't. So that's nicer. So let's do 1/5. Find the half angle values for the sine, the cosine, and the tangent. All right. Well, first thing you're going to do here is you're going to write down the half angle formulas for the sine, the cosine, and then the tangent. I'll just take the ratio of the sine and the cosine. So sine of A over 2, well, that's equal to either plus or minus. And in fact, I'll write those in blue because I'm going to talk about how to get rid of the plus or the minus, whichever one gets lost there, of the square root of 1 minus the cosine of the regular of A all over 2. And remember that 2 is within the radical. And then the cosine of the half angle is going to be, again, plus or minus. So let me write that in, plus or minus. Square root, clean that a little bit. Square root of 1 plus the cosine of the angle A all over 2. Again, the 2 is within the radical. Tangent I'll worry about later. By the way, if you wanted to substitute this in right now, you could. So I've been kind of harping on not carrying that plus or minus very long, but you could technically carry it at least one more step. So you could say these are both equal to, they both have a plus or minus right now that we'll get rid of in a moment. But the square root of 1 minus, they told us the cosine of our angle A is, I changed it to 1/5. So notice how quickly this reduces down to a done problem almost. It's almost done. However, the critical part for me and my courses that I teach is to note we need to find out where A over 2 terminates, not where A terminates. They told me the cosine of A is 1/5, but they told me A terminates in quadrant 4. Well, if A terminated in quadrant 4, that means A is between 2 pi and 3 pi over 2, which implies that dividing all three sides of that inequality by 2, that implies that A over 2 lies between pi and 3 pi over 4. So this tells me that the angle that I'm dealing with, this angle of A over 2 and this angle down here of A over 2, that angle is in quadrant 2. Because if you were to draw out an angle between 3 pi over 4, which is there, and pi, which is there, there's where your angle is, somewhere there. And so we know that A over 2 is quadrant 2 in this problem. That's how you do it. It's very fast if you know what you're doing. And now I'll just ask, if I'm in quadrant 2, these are both quadrant 2 angles, or well, this angle and this, they're the same angle, and it's in quadrant 2. We know that the sine in quadrant 2 is positive. So I'm going to keep the positive, I'm going to throw out the negative, and the cosine in quadrant 2 is negative. So I'll keep the negative for the cosine, and I'll throw out the positive. A very, very fast problem otherwise. Now I'm going to go ahead and just clean up these radicals. I'm going to get rid of the compound fractions. So multiply top and bottom of this expression here, or the radicand, by 5. If you do that, you get 5 minus 1 over 10, or in other words, 4/10, which reduces to 2/5. So the square root of 2/5. Some people really hate that notation. Some people really hate having a radical with a fraction in it. But to be honest with you, you'll have a fraction no matter what. So I just keep it like that. And let's see, the other one was a negative square root of, I'll multiply top and bottom by 5 again. So we get 5 plus 1 over 10. And that would be a negative square root of 6/10, which reduces down to 3/5. Again, your instructor might hate that you don't rationalize that denominator. I personally don't. I don't care. All right. And so now you ask, well, what is the tangent? I don't need the special formula for the tangent because the tangent of a over 2 is just the ratio of the sine of a over 2. That was supposed to be a 2. Over to the cosine of a over 2. And the sine of a over 2 is the root of 2/5 divided by the cosine of a over 2 is negative root 3/5. If you multiply numerator and denominator by the square root of 5, you'll get a negative root 2 over root 3. That's one way to write it. I would probably write it as a negative square root of 2/3. It's just my personal preference. But whatever. It's the same answer. So that's how you do a problem like this. This is probably the most popular problem involving half angle identities. Everybody loves to give this style of problem. And in fact, on exams, I'm notorious for giving problems like this. Taking a look at another problem, very similar in fact. If the sine of an angle is equal to negative 1/3 and the angle is in quadrant 3, find all trig functions of half of that angle. Well, really, all trig functions are based on the sine and the cosine. So we might as well just start with the sine and the cosine of the half angle. Again, I'm just going to write out the formulas. The sine of the half angle of B should be either plus or minus the square root of 1 minus the cosine of that angle B divided by 2. And then the cosine of half that angle B, again, from the half angle formula, is equal to either plus or minus, but not both, the square root of 1 plus the cosine of that angle B, and again, all over 2. All right, let's go ahead and dive into this. Now, this one specifically, because they did not hand us the cosine of B, notice the last problem, we were handed the cosine of our angle A, and so we were able to just plug that in. In this case, they did not do that. So this problem requires one extra step. So I'm going to go ahead and draw out the angle B that terminates in quadrant 3. Here it is right there. And they tell me that the sine of that angle is negative 1 over 3. That is, opposite is negative 1, and hypotenuse is 3. Now, again, I've said this in a previous video, and I'll say this here, that the mathematicians in the audience, myself included, would look at this and say, well, that's not, that's not technically the angle B there. So that triangle is not technically correct, but even those mathematicians likely do it this way. So just ignore that statement. All right. So, and if you don't understand what I just said, doesn't matter because math still works and doesn't fall apart here. All right. So let's go ahead and take a look at this. I can find this missing side using the Pythagorean theorem. 9 minus 1 is 8, so this is going to be the square root of 8. However, I'm going to erase that. I would write the square root of 8 here, but there are two things I don't like about that. One, the x value here is supposed to be negative, so it should be a negative square root of 8. And two, I do want to simplify that radical. That is 4 times 2, that's what 8 is. Square root of 4 is 2. So this is 2 root 2. You have to be able to quickly do that elementary algebra to survive in a calculus, or in a trig and pre-calculus and calculus course. Just have to be able to quickly throw that together. So those are all my side ratios or my side lengths for my right triangle, so that when I'm working with just the angle B, I can quickly evaluate what cosines, sines, and tangents are for the angle B. That being said, this tells me, and I'll do the same thing I did last time, I'll just keep this plus or minus going for one extra step. Just as long as I know that I'm going to have to resolve that issue and figure out which one it is, plus or minus. I'm okay with continually writing it. However, I want to make sure that in the end, one of those signs is gone. One of the plus or minus signs is gone on each of those radicals. Anyhow, I have 1 minus the cosine of B. Well, let's see what the cosine of B is. If this right here is angle B, which it's not, but it's close enough to it, it's the reference angle. The cosine is going to be adjacent over hypotenuse, negative 2 root 2 over 3. So this is going to be a negative 2 root 2 over 3. Now this is a multiplication here, so I should probably write it like that. And that's all over 2. And it's the same, 1 plus a negative 2 root 2 over 3 here. And that's all divided by 2. Now, I could continue forward and simplify, but I'm going to go ahead and take care of the fact that I'm going to take care of the half angle now. If I know that B is in quadrant 3, then where is B over 2? Well, if B is in quadrant 3, B is an angle between pi and 3 pi over 2. Some people will ask, can I do this in degrees? And the answer to that is yes, you could totally do this in degrees. However, it's better for you to practice working with radian measure because it's new to you and you need the practice. But yes, you could totally work in degrees for this style. If you did that, then B over 2 is between 90 degrees and 135 degrees. And that is a quadrant 2 angle. So I know that B over 2 is a quadrant 2 angle. I'm actually going to just place it right here. Quadrant 2 angle. That's what that B over 2 is. And I happen to know in quadrant 2, the sine, this guy right here, is going to be positive. So I'm going to erase the negative or X out the negative. And in quadrant 2, the cosine in quadrant 2 is going to be negative. So I get to X out the positive there. And now I'm almost done. It's arithmetic from this point forward. So I just go ahead and say, okay, that first one, the sine of B over 2 is going to be equal to the positive square root of, I'm going to multiply top and bottom by 3. So I get 3 plus 2 root 2 divided by 6. That's pretty much as good as it's going to get. The denominator, the cosine of B over 2 is a negative square root of, and I will go ahead and multiply numerator and denominator by 3. You get 3 minus 2 root 2 all over 6. And again, it's not much you can do with that. You would just leave it just like that. Oh, I should mention, some people will say, you can't have square roots underneath square roots. By the way, those some people, they're not mathematicians. Mathematicians and instructors are okay with square roots under square roots. That's perfectly fine. There are some very famous square roots under square roots, like this one right here. It's a very famous formula. Goes on forever, but that is allowable. That is called the golden ratio, and it goes on forever. And it's perfectly allowable to have nested square roots. Now, going back to the question, by the way, we were asked to find all the trig functions. Well, once you have sine and cosine, you have all of the trig functions. The tangent of b over 2 is just going to be the ratio of the sine to the cosine. And since the sine and the cosine both have square roots of 6 in their denominators, they'll cancel. And so it'll be a negative square root of 3 plus 2 root 2 divided by square root of 3 minus 2 root 2. This one is suspect as far as whether or not we should leave it like this. I almost feel as though in this case, rationalizing a denominator should be done, but man, oh man, it seems as though it would just be an absolute mess. But maybe I should. So I'm going to go ahead and multiply top and bottom. I'm just going to check to see. So I'll multiply top and bottom by the square root of 3 minus 2 root 2. I just want to see what happens here because it looks like something special should happen. Whether it does or doesn't, who knows? It's a negative. The denominator, because you're multiplying by the square root of itself, will become 3 minus 2 root 2. The numerator, you have the square root of 3 plus 2 root 2 times the 3 minus 2 root 2. That's very special right there. So I'm going to finish multiplying that out in a moment. I'm just curious to see what happens. So this is equal to a negative square root of, let's see, that's going to be 9 minus 6 root 2 plus 6 root 2. So those cancel. And then minus 4 times 2. In this case specifically, rationalizing the denominator was totally worth it because that's a square root of 1 in the numerator. So you get a negative 1 over 3 minus 2 root 2. Really clean, very, very clean notation. And if you rationalize this denominator, by the way, and I'll leave it for you to do, but if you rationalize that denominator, it would be a negative 3 plus 2 root 2 over 9 minus 8, 1. And so that would be a negative 3 minus 2 root 2. Very, very interesting problem if you choose to rationalize that denominator. It does clean up very nicely. And then the cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. I'm not going to write them out because they're just 1/overs or flip them. So there's no real reason for me to write them out. As a final example in this video, we're asked to graph this cosine function. And it's a cosine squared, in fact. And as I mentioned in a previous video, you don't know how to graph a cosine squared. So a trig identity has to be used. Well, in this case, because you see that x over 2, you should note, oh, that's a half angle identity. So that's going to be y is equal to 6 times the half angle of cosine squared. The half angle formula, remember, is plus or minus the square root of 1 plus cosine of x over 2. And when you square that, well, squaring a plus or a minus becomes a positive. Squaring a square root kills off the square root. And so you get that this is 6 times 1 plus the cosine of x over 2, or in other words, this simplifies down to 3 plus 3 cosine of x. And if you're one of my students, you probably already know this. I dislike the order that that's written in. So I'm going to graph 3 cosine of x plus 3. That's a much easier way of really writing that out. So let's go ahead and do this problem. Why not? We're supposed to graph it. Let's do it. The amplitude of this is 3. If you don't know how to graph a trig function, you can watch my videos on graphing trig functions. I have a whole series of them. The period of this is 2 pi over b, but b in this case is 1, so it's just 2 pi. The step size is the period over 4. So that'll be 2 pi over 4, which is pi over 2. And then the phase shift would normally equal negative c over b. But again, c in this case is 0 because we don't have a shift, a horizontal shift. But the vertical shift we do have, that's a positive 3. So I'll go ahead and grab my ruler here. And I'll just graph out a midline. In fact, maybe I should do a different color for that midline. Graph out a midline here. And that midline is being graphed at a height of 3 because that's our vertical shift. So that's done. We don't have a phase shift, so I'm going to go ahead and plot my initial graphing point at 0. Then I will go by the step sizes to plot 4 more points. 1, halfway through, 2, halfway through that, 3, and halfway in between those two, 4. Those are 4 steps, and we're going to go by step size of pi over 2. So 0 plus pi over 2, plus another pi over 2, plus another pi over 2, and yet one more pi over 2. So those are critical or key points. That takes care of that. And then finally, I will graph the cosine function. Cosine function starts tall, goes through, all the way down here, goes through, and goes back up to the top again. Connect those up with a nice smooth curve. And I'm doing kind of the same thing I did last time I did one of these problems, where I didn't leave myself room to go to 4 pi. I just went to 2 pi here. Not a big deal, but it would have been nice had I left myself some room. Oh well, what are you going to do, right? And here's my y-axis. I'll turn that off. Mark this up as the y-axis. And let's see. Amplitude is 3, right? So we're at a midline of 3 right here. Amplitude of 3. So this height is 6. This depth here is actually, the minimum is at a 3 minus 3 or 0. And now I can finally graph in my x-axis. And just do that. Obviously I missed my depth there, so I'll move that 0 slightly. Let's mark it right here. So this is a height of 0. That's the x-axis. There you go. That is, I didn't go from 0 to 4 pi. I went from 0 to 2 pi. To go to 4 pi, you would continue this on, but unfortunately I just didn't give myself enough room on this graph to do that. But that was my fault. Sorry about that. But that's how you would use half-angle identities in standard trig problems on a standard trig homework. They're all kind of this style.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry. Don't